So let's talk a little bit about moving light beam control. So the moving light beam is altered in the exact same way as color and everything else. We just use these discs, right, that move different gobo images, different images into position in the optical path. We also have an iris that's located somewhere in here, right? And the iris, just like on a camera or your eye, closes down the circle of light so that it's smaller and tighter. We can also then control the zoom and the edge by varying where the lenses are in the optical path, right? And then there are special effects that are on the often on the very front, and those are prisms, or sometimes there's animation discs, or there are a variety of special effects. And then last would be framing shutters, and those are just like shutters on an ERS spotlight, where we can cut off a side of the light. We could square things off, right? So that's all under moving light beam control. What I want to focus on, or what I'll show you in this video, is going to be the gobos and gobos in moving lights, right? So the gobos are organized on wheels, right? And so a motor in the center is able to move this wheel from its open position to insert this gobo in the optical path, which means that then the light is going to project that image. Or if I move to this, it's going to project that image, or this bark, or water, or flames. It'll project whatever gobo is here, right? So there's always an open position on a gobo wheel, and then a series of gobos around that spins. And you can see some of them here. Now, sometimes they are steel, right? They're metal, and you can see a metal gobo here, but sometimes they also have color. And so a color gobo requires glass. And you can see that this image wouldn't survive very well with its little points if it were made of metal. And you definitely couldn't get the color if it was made of metal. So you can see how they're organized, or how they're made of metal and or glass. Now, these gobos are really small. You can see the size of this gobo, and this is a typical size for a gobo. It's only a little bit bigger than your thumbnail. It's not like a traditional gobo for a Source 4, that's 3 or 4 inches around. These are really small, so oftentimes less than an inch, because there's not much room inside of these fixtures. You'll also note that the gobos are mounted on this geared assembly. These gobos can spin, and there's two kinds of rotation, right? There's two kinds of rotation that a gobo can achieve. One is called index, and when we index a gobo, that means that we adjust it until it's at a specific angle, and we record that angle into the cue. Now, every time that moving light goes to that cue, it's going to spin that gobo to that angle and then repeat it. And you could think about the idea that if we had a logo for a company, say we even had the FSU logo that's loaded on or printed on a gobo, when we project that onto the wall, we want that to be right side up. We want to be able to look at it in the correct orientation. And in order to do that, I have to be able to index that gobo to a very specific angle and then save that in a cue. The other kind of rotation that we can have is spin. And that's to be able to take that gobo and just continuously spin it. And these gears that the gobo is mounted in, they allow us to index and to continuously rotate. This gear is driven by this belt from this motor. You can see that this all gets very complex. I have to be able to spin this wheel and spin these gobos. It gets to be quite a process. But we can spin a gobo or we can index a gobo. Let's take a look at some gobo wheels. Right? So moving lights will often have more than one gobo wheel. And if we take a look at our techno spots that we have in the light lab, you'll see that I have gobo wheel 1, and it has a triangle and this little tie-dye pattern, and we have the Hollywood stars, not the skull, so if you're looking for the skull, forget it. And then this like sunburst and construction gobo, and then leaves, and then obviously the open position. And all of these gobos can be indexed or rotate. And then the open. Now, we also have a second gobo wheel 2, and it has entirely different gobos in it, right? So it's got lots of dots. It's got this bark sort of water texture, this little sunrise thing, this red circle or white circle in a red background, and a Gatling gun, which is just a blue field with little no color dots around the edges, right? And so the cool thing is that I can put a gobo, I can put one gobo in on gobo wheel 2 and a different gobo on gobo wheel 1, and it will project both images. So if I have this litho texture, this watery sort of looking gobo behind the triangle is going to be filtered, right? And I'll only see the triangle, and then I'll see just a few little ripples behind that triangle. So the two are combined. Now, the gobos exist at different places in the optical path. And they're just like a source 4. You can focus sharp to a gobo. I can focus sharp on whichever gobo I want. So I can focus sharp on the triangle with this image sort of fuzzy in the background, or I can focus sharp on this image and the triangle shape is kind of fuzzy. It's called gobo morphing. It's really beautiful. And I just, and it's hard to explain, so I thought I would just play you a couple of seconds of a video demo of this fixture. Okay, so that was a just kind of a few seconds of that demo, and they were cheating a little bit. They even were using multiple fixtures, but you could see how it was sharp on some gobos, and then it would change, and it would be sharp on other gobos. They were also adding special effects like prisms, yeah, so there was a lot going on in that video, but at least it gives you a little bit of a sense of what the capabilities are of being able to put two gobos in and then focus on whichever one you want. The thing to remember is you won't be able to focus on both images sharp at the same time. So that's what we have for moving lights. Yep, I think I'm done. So, bye.